I don't typically tell on myself, but my control panel may be a bit of a rat's nest on the inside. Let me show you. Not my proudest moment. When I first started putting this together, I was doing a good job of putting all my wires together, soldering all the joints, heat shrinking everything. It was going pretty good. And then I got an order in, and this had to be done in a day. So I kind of went and used all of the components I had as quick as possible and tried to get this in working order, which it does work, but it's just not very pretty and definitely not very practical. As you can see, I can't even take the lid off of it without unconnecting 3 different connections. So today my goal is to kind of clean up the inside of this control panel and then show you the insides and the guts of this and kind of how it all works and what I'm doing to upgrade it a bit. Hope you enjoy. Alright guys, this is my upgraded control panel for my CNC, and it looks the exact same from the outside, I'm sure. Before we start, just so you know how this is working.
This is a wiring diagram of my control panel since I've upgraded it. As you can see, you've got 120 volts coming in to a DC power supply, and then from the DC power supply, you've got 12 volts DC coming out. From there, 12 volts goes to the CNC machine, where it goes to all of the normally closed limit switches around the machine, and then the 12 volts comes out of the CNC machine and goes to the emergency stop push button on the front of the panel. And as long as none of the limit switches are tripped and as long as the e-stop button is not pressed, 12 volts then goes to a 12 volt relay, and it allows power to go through the normally open contacts to the rest of the system.
Right now I have the machine jumpered out, so it thinks that the e-stop loop right now in the CNC machine is running and just fine and not tripped, and I did this by just installing this little jumper real quick. So this is the front. I've talked about this in my last video. This switch controls my spindle on and off, and you can't see it, but there's actually a receptacle built into the front right here, and I can plug in a wood burner or my router or whatever I want to plug in there, and it's controlled through this switch, and that's 120 volts down there, so good to go. This is the e-stop for my whole machine. When I press it, the emergency stop loop shuts down and it kills my spindle, and it kills the power to my Grbl Shield, stopping all my servo motors. And that's also very useful. Up here you've got my display. It shows the power, so I can tell I've got 12 volts going on inside. That's great, and it tells me how much current I'm pulling for my Grbl Shield. Right now it's 0 because I'm not connected to my CNC. Pretty much the power and the energy at the bottom, I don't look at those so much. The voltage is good because I know that the DC power supply is working. But the current's great because I have a general idea of how much power my Grbl Shield typically pulls, and if it's pulling more than that, I know that I'm running with I'm running too fast at speeds, or that my spindle speed's too slow. So helps me fine-tune things as the machine's running. So it's a good little addition, but not necessary at all. So this is what the inside now looks like. Still not the prettiest thing in the world, but it's better than it was. I've installed the Molex connector. All of the connections are soldered, and I put heat shrink around every single connection, and then I put an overall heat shrink around the bundles. I put in some cable management around the outside just to make things a little bit prettier. And as I kind of talked about earlier, I installed 2 normally closed contacts on the e-stop, and I'll explain that now. So the white wires go to part of my e-stop loop, and that's my 12 volt DC loop that goes through all of the limit switches on my CNC machine, and it goes to this e-stop. So whenever I press this e-stop, it opens up the loop and it closes, or I'm sorry, it opens this relay. And whenever that relay is open, that means that it shuts down the Grbl Shield, and it also shuts down my spindle, and that's my solid state relay that controls the 120 volts to my spindle. And that's great. So if my CNC machine bumps into one of the limits, that means it's definitely not where it's supposed to be, and it could start, you know, bashing itself against the wall, and it could start problems, so it stops the machine, which is great. The only issue is if I had the e-stop loop, or the e-stop pressed, or a limit switch on the emergency stop loop was tripped, it shut everything off, which was good, but if I had this switch in the on position, the spindle's done. It's not moving because the e-stop has been pressed, or a limit switch was tripped. And there's not 12 volts going to this, so it shuts everything off. But if I move the gantry around, the servo motors actually turn into little generators whenever you move them, and they caused power to backfeed from my Grbl Shield to this relay, and it would turn on my spindle. And that was a scary time the first time that happened. Thank goodness my hands weren't on the spindle, but it freaked me out. So after that, it was a hard-learned lesson that whenever I move the gantry, I make sure that this switch is in the off position. But it's something easy that you can forget, so I decided to do something about it. I had two choices on how I could feed or stop the Grbl Shield from backfeeding into my emergency stop loop, and I could either A, put a diode in, or I could open up the Grbl Shield contacts whenever the e-stop's pressed. A diode would have worked. It would have kept current from backfeeding into the system. The only problem is if the diode had to block more power than it could dissipate, then the diode could burn out, and it would be an issue all the time. So I was afraid to do that because I didn't want to burn out any diodes. So instead, I installed another set of normally closed contacts, so whenever I press the e-stop, not only does it shut down the emergency stop loop, but it completely opens up the circuit from the Grbl Shield to the rest of the system. It completely isolates the Grbl Shield, which is what I was going for. So that's a good little feature. In here, and I'm going to just try to make it so you can hear what's going on. So I just opened up, or I turned on the machine. So I opened up the normally closed contacts are now closed because the button's not pressed. You can see the Grbl Shield has power, and the relay does not have power, but the e-stop loop is live. And if I flip this switch, you can see this relay down here. The light turns on and off for the spindle, and again, that relay just feeds directly into a 120 volt outlet I have plugged on the side. And as you can see here, if I press the e-stop, it also shuts off that relay, which is a nice little feature. Elsewhere in the control panel, this is just where I've got a little terminal strip. I've got 120 volts on the right, which I'm not touching in there. I try not to break the plane of where the top is. I know I've probably broken that rule a few times here, but that's why I try to pretend it's still there. So be careful if you're working in live stuff. I have 120 volts on the right, and then in the middle I have my 12 volts, and on the left side I have more ground type stuff. So that's kind of how I did this whole system. Over here you have the shunt, and this shunt is what tells how much power the Grbl Shield's pulling. So that shunt is connected to this, which makes the amperage change based on how much power is being pulled. Down here, this is my terminal strip that goes towards my emergency stop loop. So it kind of ties into everything down there, and it's just convenient. Again, I've got my Grbl Shield down here. The Grbl Shield is great. I really do like it. It's been working fine for everything I need. The only issue I have with the Grbl Shield, and it's not really an issue now, but those chips, the driver chips on that board, get super hot if you turn up the current to the steppers, which you really need to turn up the current if you're doing anything that has any sort of resistance against the movement of the steppers. And I actually had my machine go into thermal overload a few times, which is where the servo motors, or I'm sorry, the stepper motors start kind of freaking out. And I figured out the reason was those drivers were getting too hot and really causing some issues for me. So to fix that, I put a little PC fan in here, and it blows across the drivers on the Grbl Shield, and that's fixed all my problems. I haven't had any issues since. I do plan on putting some sort of heat sinks on top of them someday whenever I remind myself to go buy some thermal paste. And then on the Arduino underneath, I just put a USB cable out the side of the machine, put a little cable gland at the end just to keep it from being pulled out. So that is the inside of my control panel. I hope this gave you some ideas of how to make your own. Again, I am no expert at electronics. This isn't my deal. If you've got any questions, comments, or suggestions on how I can improve this, please let me know. Again, I know this isn't the prettiest control panel known to mankind. Some cable management is really required here, but it works pretty good for me. And with these little upgrades that I've done, I feel that this is going to work really good going in the future and doing my other builds. So thank you very much for watching. Have a great day.